Right, so here what I want to do is have a look at the determinant and the inverse of 2 by 2 matrices. So before I do that, I just want to have a quick look at the properties of matrices, multiplying matrices. So for example, if we take one matrix A and multiply it by B, do we get B times A? In fact, you'll find you won't. You'll get a different matrix. So we'll say that multiplication is not commutative. So multiplication is not commutative for matrices. Now, what about the associative property? Well, if you take A, multiply it by B, multiply it by C, so you've got three matrices here, multiply them out. Now, we put a bracket around A and B, so we're going to do multiply A and B first, and whatever we get then multiply by C. You will find that the associative property does hold. So A times B times C will actually work if we multiply B by C first and then multiply by A, we'll get the same answer. So it is associative. So the associative property holds. Now the other property then that we can have a look at is A times B plus C. So this is the distributive property. So you'll find here that you can multiply A by B plus A by C, and that's the same as, say, adding these two and multiplying by A. So the distributive property works. Distributive property will work as well for matrices. And also, in fact, if you do this the other way around, B plus C times A on this side, what you need to do here is B times A plus C times A. So the distributive property works here. Okay, so another property that I just want to have a look at is what's called the identity matrix, and we'll call this the identity matrix I. So in normal algebra, for example, or just normal multiplication, if you have the letter x and you multiply that by 1, that's exactly the same as 1 times x, and you'll just simply get x. So 1 is the multiplicative identity. So you multiply 1 by anything and you'll get the anything if you like. Now, you can do the same with matrices. You can multiply matrices by another matrix called the identity matrix. So if we multiply matrix A, for example, by I, we will get A. We will get A. So multiply A by I and you'll get A. And it also works in reverse as well in this case. So it is commutative in this particular case. So you can take A, multiply by I, you'll also get A. So whereas multiplication is not commutative normally, it is commutative when we're talking about the identity matrix. So what is the identity matrix? Well, if you take, let's say, a 2 by 2 matrix, let's say, I don't know, 2, 3, 4, and 5. This is our matrix, and we want to multiply this by some matrix here, which is the identity matrix, and we want to end up with 2, 3, 4, 5. What can we multiply this by to end up with the same matrix? Well, if you imagine how you actually multiply matrix here, you're going to multiply this row here by this column here. So what we want to do is multiply something by 2 to give us 2, and then get rid of this 4 here if you like. So if we multiply, let's say, I'll just put this in blue here, let's put 1 here. So if I multiply 1 by 2, I'll get 2. But I also must multiply this by 4 and add it to it. But I don't want 4, I want to leave 2 as it is. So let's put in a 0 here. Let's see, does that work? 1 times 2 is 2, plus 0 times 4, which is 0. So I still get 2 here. That's perfect. Now, if I look at this one here, I need 4. I need to multiply this this out again and just end up with 4. So I need to start here, multiply this particular part here by 2, and then add whatever this is by 4, and my answer has to be 4. So again, if I put 1 here and multiply by 4, I'll get 4. But I don't want this 2 here, so let's put a 0 in here. So 0 times 2 is 0, plus 1 times 4 will give me 4. So that works for this part here anyway. Let's see, does it work for these two here? Well, 1 times 3 will give me 3, plus 0 times 5, that will disappear, so I'll just get 3. Okay, perfect. 0 times, now this time I want a 5 down here, so 0 times 3 will give me 0, plus 1 times 5 will give me 5. So this here is my identity matrix here. Perfect. Now this, you can see, is a 2 by 2 matrix, and what you'll actually find is that all identity matrix will be square matrices. So this is what we would call I2. There are identity matrices for 3 by 3. There are 3 by 3 identity matrices, what I should say, and rather than writing it out, you could just write down I3, because it's simply going to it'll look like this really. It'll be a 3 by 3 matrix, so it will just be 1 0 0 0 1 0 0 0 1. So you can see the ones here are in the diagonal of the matrix, from top left to bottom right, and everything else is just a 0. So this would be my I3. There's also an I4, I5, and so on. Okay, so they're all square matrices, as you'll find out. Okay, so anyway, let's have a look at what we were going to do initially, which is looking at determinant and the identity matrix, and how do we find the identity matrix for any particular matrix. So now I'm going to look at 2 by 2 matrices in particular. So let's have a look at what's called the determinant first of all. So we're going to look at the determinant. Okay, so if we take a matrix, any matrix, let's say, well, I'll just put in A, B, C, and D. You need to be able to work out this determinant first of all, and that's just simply the determinant of this particular matrix here. Let's call this matrix, again, we'll call it A. You would write the determinant like this. The determinant of A is just simply equal to AD, so whatever is here multiplied by D, and then subtract C times B. And whatever you get here, that's called the determinant of this particular matrix here. So for example, if we have, let's say 2, 4, I don't know, 1 and 7. Okay, so this is our matrix. To work out the determinant of this particular matrix, we take 2, we multiply by 7, and then we subtract 1 multiplied by 4. So if we do this, 2 7s will give us 14, and then minus 4, so we will just get 10. So the determinant of this particular 2 by 2 matrix is 10. Now, how are we going to use that? Well, what we're going to do is use it to work out, we'll use this matrix again, we'll use it to work out the inverse of this particular matrix here. So let's work out our inverse. So the way you work this out is you would, if we take our A, B, C, D, I'll just start with A, B, C, D again. So this is our 2 by 2 matrix. The inverse of this particular 2 by 2 matrix here will be 1 over the determinant multiplied by, now what you need to do here is take the A and the D and reverse them. So I'm going to put D up here, the A down here, and then I have a C and B here. What you do here is just change the sign of the C, change the sign of the B. If you do all of this, you will get the inverse. So this will give us the inverse of this particular 2 by 2 matrix here. Okay, and what you'll actually find is when you multiply a 2 by 2 matrix by its inverse, you'll get the identity matrix. We'll have a look at that in a minute anyway. So let's continue with this one here. So I'm going to move this one down here. That's 2, 4, 1, 7. We'll work on that one and see what happens. So we have 2, 4, 1, and 7. Now we worked out the determinant for this, and we worked it out as 10. So remember what we have to do to find the inverse of this. So the inverse of this matrix is going to be 1 over 10. Now we've got to reverse these two, so I'm going to put the 7 up here. I'm going to put the 2 down here. I'm going to take the 1 here, change the sign. The 4 here, change the sign. Let's just work this out. What will I get? I will get 1/10 of each of these numbers, so it will be 0.7 minus 0.1 minus 0.4 and 0.2. So this here I'm saying is the inverse of this particular 2 by 2 matrix here. So what happens if I multiply this matrix here by its inverse? We should get the identity matrix. So let's just have a look at doing that. 2, 4, we'll start with 2, 4 here. So what I'm going to do, if this, again, let's say this is A. So what I'm going to do is take A, multiply it by its inverse, and I should get I. Now, that's the identity matrix, 2 by 2 identity matrix. Also, that will be, this will work in reverse as well, in fact, so I can take A inverse multiplied by A, I'll still get I. So let's have a look at doing that and see, does it work? Let's see, 2, 1, 4, 7. I'm going to multiply that by its inverse, 0.7 minus 0.4 minus 0.1 and 0.2. Okay, let's see, does that work? Well, what happens here is I get 2 times 0.7. So let me just get a calculator out here. We'll just make sure we have this right. So what I need to do here is multiply 2 by 0.7. So I had 2 multiplied by 0.7. And then I have to add 4, 2 times 0.7, and then 4 times minus 0.1. So it's 4 times minus 0.1. Whatever this is, this will be the first part, the top left part of my 2 by 2 matrix. So that's that bit there. Okay, so let's say this one down here now. So it's 1 times 0.7, so that's just going to be 0.7. And then I've got to add 1 times 0.7, and then 7 times minus 0.1. 7 times minus 0.1. Okay, so that's the first two. That's the first column down of my my matrix. So now let's do this one up here. So that's going to be 2 times minus 0.4. 2 times minus 0.4 plus, that's 2 times minus 0.4, 4 times 0.2. 4 times 0.2. Now let's do the last bit here. So that's going to be 1 times minus 0.4. 1 times minus 0.4, well that's just minus 0.4, plus, so I've done 1 times minus 0.4 plus 7 times 0.2, so that's 7 times 0.2. Okay, so let's work all this out. Whoops. Let's just move this up a little bit and see what we end up with. Okay, so it's going to be a 2 by 2 matrix anyway, so we've got 2 times 0.7, so 2 times 0.7 will just give me 1.4, and here I'm going to end up with minus 0.4. So I'm going to, this part up here will just be 1.4. I'll do it, actually I'll do it over here in a different color. Just this bit here now. So I have 1.4, and then subtract 0.4 times 1 is just going to be 0.4. So here I'll just end up with 1 here. So this will give me my 1. So that's a good sign so far anyway. Now what about, let's say this one here. Okay. So I have 2 times minus 0.4. So that's just going to be minus 0.8. And here I end up with plus 4 times 0.2. And that will give me plus 0.8. So you can see here I'll just end up with 0. Okay, so that's a good sign. So let's see what happens here. Here I've got 0.7 plus 0.1 times, or minus 0.1 times 7. So again, that's just going to cancel out, and I'm going to end up with 0 here. And down here you can see what this is going at this stage. So 1 times minus 0.4, minus 0.4. And here I end up with plus 0.2 times 7. So that gives me plus 1.4. So plus 1.4 minus 0.4, that's just going to give me 1. So look, I ended up with the identity matrix. So in other words, when you take a matrix, multiply it by its inverse, you will get the identity matrix here. Okay, now just going to do one more thing, and then we'll leave it at that. Let's say you have a matrix, let's say A. We'll multiply it by B, some other matrix, and let's say we'll get some other matrix called C. Now, let's say, for example, this is an equation with matrices, so let's say we don't like this A on this side. We want to try and isolate B. We want to get B on its own here, so we want B is equal to something. So we've got to get rid of this A here. So how are we going to do that? Well, we know that if we multiply a matrix, by its inverse, we'll get the identity matrix. So if I take A and multiply it by its inverse, let's say A power minus 1 is its inverse, I know I'll get the identity matrix. So let's multiply both sides of this equation by A inverse. Let's say I want to get rid of A from this side of the equation. So what I'm going to do here then is I'm going to take A inverse, multiply it by, I'm going to multiply it by A, B. So what do I need to do then? I need to do exactly the same on this side of the equation. Take A inverse, multiply it by C. So what will that give me? Well, A inverse times A will give me the identity matrix times B. So over here I'll end up with A inverse times C, and we know that if you multiply any matrix by the identity matrix, you'll just get the matrix itself. Okay, so this will just become B, and over here we'll end up with whatever A inverse C is. Okay, so that's the idea anyway. So yeah, well, that's about it really. You can try that yourselves. I mean, if you take, well, maybe I'll do one here. Sure, why not? Let's take. We have a matrix and we have its inverse here. So let's see if I can, if we can do this. So let's take 2417. So we're going to take 2417 again. Okay, so 2417. So I'm going to take 2417. So this matrix here, and I'm going to multiply this by some other matrix. So let me just make something up. I don't know, 1, 2, 3, 4. Okay, so if I multiply those two, I'll get 2 1s are 2 plus 12. Let's see, I'll just put the answer over here. 2 1s are 2 plus 3 4s are 12. So that'll give me 14 here. 2 2s are 4 plus 16 will give me 20 here. 1 2 is 1 1 is 1 plus 3 7s 21, so that'll give me 22 here. And let's see, 1, 2 is 2, 4, 7 is 28, so that'll give me 30 down here. I think that's correct anyway. Let me just double check that again. 2 ones are 2 plus 12 is 14, and 1 is 1 plus 3 7 is 21, that gives 22. 1 2 is 2 plus 4 7 is 28, that gives 30. 2 2s are 4 plus 16, 20. Yeah, it seems okay anyway. Now let's say I want to get rid of, this is my A here if you like, I'll do it in a different color. Let's say here, this is my A, this is B, and this is C here. Now I want to get rid of this from this side here. So we already have the inverse of this here. So I'm going to multiply both sides by the inverse of A. So let's do that then. Now the inverse of A, as we saw before, was 0.7. 0.7 minus 0.1. It was minus 0.4 and 0.2. So I'm going to do that here, then I'm going to multiply that by 2417, and I'm going to write this down, 1, 2, 3, 4 here. And over here then, now I multiplied by the inverse, this was the inverse, so I got to multiply this by the inverse as well. So let's just write all that down. So we got 0.7 minus 0.1 minus 0.4, 0.2. I'm going to multiply that by 14, 20, 22, and 30. Okay, so I'm running out of room here now, so it's going to get a little bit tight. So this here, these two here will just give me the identity matrix. So this will just give me I. And here I've got 1, 2, 3, 4. So really this just becomes 1, 2, 3, 4 on this side. I've isolated this particular matrix here. And over here then I should get 0.7 times 14, 0.7 times 14 plus, or in fact minus, I've got to do this times 22, so it's going to be minus 0.4 times 22, and that gives me 1 here. So I would expect that, look, I've got 1 here. Okay, so let's do this one here then, this one over here, let's see. 0.7 times 20, so we're going to multiply 0.7 by 20, and then minus 0.4 times 30, so that's going to be minus 0.4 times 30, that's just going to give me 2, and that's exactly what we want, 2 here. Okay, so let's do this one down here now. So that's minus 0.1 times 14. So that just gives me minus 1.4. So we start with minus 1.4. And then 0.2 times 22. So plus 0.2 times 22. And that will give me 3. So that's perfect. I get 3 here. And last one then, we're just going to do this one down here. So it's minus 0.1 times 2, so that's just minus 2. So I start with minus 2. And then 0.2 times 30, so it's plus 0.2 times 30. That will give me 4. So you can see we ended up with the same matrix again on both sides here. That's it really for the identity matrix, 2 by 2 matrix, the properties of matrices, multiplicative properties of matrices, the determinant, and the inverse.